And everybody clears the message from their screen. Okay. So anyway, as I was saying, a lot of hands-on and a lot of explanation, but it's geared towards beginners and people who know how to do this alike. But I wanted to explain what got me to this point. You know that I'm building a lot of radios and talking about them a lot on the air, following a lot of what's going on in the ham radio industry, we'll say. And radios I've been talking about a lot is, this board. This is an unbuilt one, or partially built. This is that true SDX. One example. There's another couple of radios that got me into this line of thinking. This is the Hans Summers QRP Labs QCX Mini. It's a great little monoband CW rig that has a lot of features. This is same company, their little digital radio, the QDX. It's a quad or technically 5-band digital radio for like FT8 modes and such. What do all these things have in common? This chip right here. This is an Atmega 328P. It's a microcontroller. And there is a book you can buy from Amazon called Microcontrollers for Ham Radio. It's a whole book of projects and theory. And this is nothing new. A lot of the more sophisticated radio kits that have been around for years are based on microcontrollers at their center. That's how they work. That's how they know when you push this button, it means bump the frequency up 5 kilohertz. It knows when you push this other button to change the amount that it bumps the frequency to 1 kilohertz. And then when you hit up, it goes up 1 kilohertz. It's taking the input of all the buttons, it's creating output onto displays, but it's also, in cases with these, helping to get the frequency synthesizer to go to the right frequency, read what's going on the radio and putting it back onto the display. There's more and more that they can do in radios with microcontrollers. So, the reason why I came to this path and I keep harping on this subject, this is the finished radio of the board I held up first. Two very talented guys, DL2MAN, PE1NNZ, figured out how to shoehorn enough code onto one of these AT328P chips to actually create sideband signals and demodulate them. It's not using the normal hardware to create upper and lower sideband, and it's not using the normal product detector methods to decode it. So there's a very, very small amount of components in these radios compared to their counterparts that do the same thing. But that just intrigued me. It's, I've been buying microcontrollers for a while and using them in projects where I simply just grab the code and load it onto them. But they work to even get to that point sometimes. The fact that they're able to get that far with it, I found really interesting. So a lot of people who head down this road, they hear the word programming and it scares them. A friend of mine just joined us, so programming is not necessarily something to be afraid of, and I think it's why a lot of people into this part of the hobby. When you look at what I'm going to demo and you understand what's going on, in the same lines that I do. And a lot of you know that I'm an IT guy. It's what I do for a living. I'm not a programmer. I did take some programming years ago. I took some classes 3 or 4 years ago when I went back and got my degree. I still can't sit down and just bang out code for something. If you show me example code, I can modify it to do something else, or I can take snippets of other pieces of code and make them do what I want to. If you show me a block of code that's not working correctly, show me what it's supposed to do and what it might be doing. I can probably help you troubleshoot it, but I can't just sit down and write a program these days. I could if I really started spending a lot of time on it, but I have enough that I follow and enough that I do at work that I really don't need to become a programmer. So programming one of these microcontrollers is relatively simple. And just so early on in ham radio, a lot of the early projects used what we called Pic Microcontrollers. And these were simple 8-bit and later 16-bit microcontrollers, really simple things. And there were a whole series of these. Much earlier technology than what we're doing today, but something like the Atmega 328 is really not that far beyond some of these. And those of you who got into some of the early maker stuff that Radio Shack was doing, probably remember the Parallax series of microcontrollers that they sold. And but what really is a microcontroller? When you hear that name and you think of it in regards to a full-fledged computer, you'd think, well, a microcontroller is any computer, a less powerful computer, a less capable computer. But let's look at something here. The Commodore 64. You know, there were a lot of those out there, and a lot of us, including myself, learned how to write programs on these things. And for a lot of people, it was their first introduction to computing in the 80s. It really was one of the first really affordable home computers. Let's look at the specs. So it used an MOS 6510. That's the main brain that was in this thing, running at 1.02 megahertz. That's really speedy by today's standards, considering that we're in the 2.4 and higher gigahertz level on a lot of desktops. It had 64K of RAM. Here's the Atmega 328P. We're talking about a 20 megahertz processor. It's a different kind of processor, so it's much more efficient. So this 20 megahertz is not 20 times the speed of a Commodore 64. It's probably more like 200 times the speed of a Commodore 64. Only 32K of flash memory. So we're faster, but not a whole lot of memory. And that's one of the reasons why you have to be very efficient with your programming with these, which is still, to me, more of a miracle of how Manuel and Guido managed to shoehorn sideband code into one of these things. But anyway, and they come different ways. Like this is the one that I showed you that was on the Elegoo generic Arduino. I have another official Arduino board here that uses this package, which is really tiny. 4 of these would fill a postage stamp, but still the same processor. And when we get into Arduino, then it's all loaded onto a board. This is what they look like. And this is what we're mainly talking about tonight. So there are other microcontrollers. This is the start of a much larger presentation that I want to do on this, incorporating some videos with some of the things we're going to look at tonight. But I'd rather do more of a live thing here. Anyway, this will help you figure out and understand what's going on. There's the chip you're talking about. And everything else here is for supporting that chip. So one of the big things you do with a microcontroller is control the world outside of the board and sense what's going on in the world outside with the board. And you have what we call GPIO, or general purpose input output, or buses, rows of these. These are the digital interfaces. And on this side, we have some analog interfaces. And then the rest of this is all support. Voltage. These are voltage out to drive other devices from. Ground. You power this thing, you can power it through a USB host, power connection, 5 volts, or you can feed it with a regular 2.1 millimeter coax power connector, in which case this little thing here, voltage regulator, excuse me, that allows us to feed this thing with, I think, up to 12, maybe 14 volts, 20, excuse me, 20 volts. So you can feed this thing with anything from 7 to 20 volts, and it'll knock it down to the required 5. There's lots of generics. The one here in the picture is the one I keep holding up with the chip on it. This is readily available on Amazon, very close to the original. It does have a couple little extra things on it, like this little pin bus. You'll find a bunch of these. There's lots of Arduino boards. The Uno is simply the most popular for learning projects. And because it uses the Atmega 328, it's a good example for the things we're talking about that are radio related. But there's a lot of them. See, these are all official Arduino boards from the Arduino project. And then there are things that branch off of this as well. So that's where we get into talking about other microcontrollers. The Raspberry Pi Pico is a new board from the people who make the Raspberry Pi that pretty much does the same thing as an Arduino. And it's not a full-fledged computer like the Pi. The microbit, which we'll take a look at, the microbit is from the BBC. Yes, the same BBC that does the news. They've subsidized another computing project to get kids learning how to program, which is what the original BBC Micro was in the 80s, a competitor. British government subsidized to get computers into students' hands. The Raspberry Pi, the actual Raspberry Pi, is a project that was started in that same line of thinking. That's what the Raspberry Pi Foundation was thinking of when they came up with a simple, low-cost computer geared towards children learning how to program. I listed that here as well. The Pic Microcontrollers, which we already talked, and there are many, many more of these. One of the ones that's come up recently is we talk about the Teensy, ENSY line of microprocessors. They're basically it's on steroids, much faster and much more memory. There is a project coming up from Jack Purdom, W8TEE, the same guy who wrote the Arduino for Ham radio book. He has a new book about the T41 Transceiver project, which is a software-defined radio built around the Teensy 4.1 processor. And there's a whole book on the project, step by step, and all of the theory to do it. And sometime in the next 4 to 6 months, the 4-state QRP Club is going to be selling a kit for this radio. It's a 5-band, 20-watt sideband and CW software-defined radio rig with a full color display, touchscreen, and everything. Well, actually, no, it's not a touchscreen. They didn't want to go that complicated, so it's got buttons, but it does have a really nice color display. So programming. So this was what I was saying a lot of people get afraid of. Here's a Blinky is what usually people will call this line of code. In the regular programming world, when we talk about writing programs in Python or C or C++, the popular modern languages, and any of the old languages too, like Pascal and Business Basic and Regular Basic and Modula 2 and so many of the older languages, the first program most people write is called Hello World. And what does that do? It just, you run it and it returns the phrase Hello World on your screen or on whatever display you've created to use with that device. So in Arduino land, or microcontrollers in general, the first program people usually do is called Blinky. And what it does is it just turns an LED on and off. So this is just a loop. A lot of these terms like void setup are in every program at the beginning that you write here. Pin mode is telling us that we're going to use the LED built-in function as an output. We have a loop. It's telling us that the loop is beginning. We are writing through a digital pin. I showed you we have both digital and analog pins. So we're writing through a digital pin, LED built in, high. High means on, basically, in our digital terms. And delay 1000. The numbers are in milliseconds. So 1000 milliseconds is 1 second. So we're delaying 1 second. Digital write, LED built in, which is the LED pin in the digital bus, low, or in our case for digital, off. We're turning the LED off, and then we're waiting another second or 1000 milliseconds. And then the loop ends here and runs back up to the other bracket here, and it does it over again. This will keep going till we end it. I mean, if you know what it's doing, like I said, you can look at this code and you can understand what's actually happening here. You know, like I don't know that this term counts in milliseconds, but I know that it's telling me it's waiting a second. It kind of makes sense that it would be milliseconds then, because it's 1000, it's an even number. Everything else here, if you know that it's turning the LED on and then turning it off, you can kind of relate that back to what's actually happening. So there's the code again. And it's a specially modified version of C, or C++ in this case, reworked for the Arduino boards. Not all these boards have to take that code as their input. The code is compiled. It's loaded into the board. And that's done with something called the IDE, or Integrated Development Environment. Any kind of programming usually has this interface when you're dealing with a device, thing called an IDE. And that's where you put this code. And when you're done debugging it and making sure it's okay, you compile it, and it loads a much more complicated, lower level, faster to execute code into. Now, there are people in this world that can actually sit down and write machine code and assembly code. I admire them. I can't even think about doing that, but it is possible. It's quite the art. But no, we prefer to write in high-level languages, which is what these are, and do it this way. Now, all of these languages pretty much are compiled, but back, any of you who learned to program in the 80s, and we learned in BASIC, that was an interpreted language where when you run the program, it's actually not compiled, but interpreted into machine code line by line as you go along. And you can think that one of them would definitely be more efficient than the other. Term we have to bring up with before we get into this is libraries. And this is one of the things that makes Arduino and a lot of other device programming easy, is that you get to use things called libraries, which in programming terms, to some people who have done programming before, are functions or subprograms. And these are basically groups of precompiled code that tell your program how to use certain things or do certain things. So if we're using a standard 2-line LCD display, which we'll get to see working tonight, there's a special library that tells the Arduino how to write text to a 2-line LCD display. If we're using a standard OLED display, and any of you have EMR hotspots at home with a display on it, that is a standard OLED monochrome display. Some of them are 2-color, 3-color, but they're really pretty simple. It's another really, really popular display. Or it could be something that's telling us how to communicate with a Silicon Labs SI4735 chip, which is a chip that's in most portable shortwave radios these days. And that's how they work. They're addressed by a microprocessor. So there's libraries for all of these different devices, and you're going to find you're going to need to load them along with your program. And the program, the code, will tell you which libraries you need. And you can search for them and load them along with your program, and they all get loaded into your Arduino. So what's next? The things we can do is there's lots of code out there. My first experience with an Arduino at all, ever, was with creating a fox hunt transmitter. So, we just had the direction finding event. I used to do a lot of that down on Long Island, and I made my own fox hunt transmitter out of tiny Baofeng UV3 and an Arduino board. And if you look for code online, you'll find it. So like this is an example we're going to look at tonight. This code is here. It's open source. I can grab it and I can just load it into my Arduino. So this is one example. There's another one here, and we're going to look at this one. Most of the writing you see here is comments, explanations. The actual code for this program is only this long. Some of these are very simple. Most complicated program that we're going to step a toe into tonight is about 270 lines long. We're not going to look at the code for it at all, but you'll see it in action. And just to give you an example, that T41 software-defined radio project that I'm talking about, not on an Uno, it's on a Teensy 4.1, which is a much more powerful microcontroller. It's still a microcontroller, not a full-fledged computer, and that one has 12,000 lines of code. So not something I feel like playing with right now. So I discovered recently that a really cool way to play with this stuff, simulator. This is Wacwi. There are other simulators out there, but this one is really cool. I found it really easy to use. It's just if you just throw this in your address bar or your Google search, Wacwi, W-O-K-W-I. First get into this, it asks you what board you have. And you can see there are different boards here, including the Pi Pico, but we're using the Uno. And you get the basic void setup, void loop. You have to keep this there, but if you want to just start writing your own code, you would write it here and here. So this is a simulator. And what we can do with that is create something like Blinky. So This is the entire code. And once again, this code has a lot of text in it explaining what it's doing. But I'm going to copy it, Control C, and place all of this. And those of you who don't know those shortcuts, these are standard to almost any piece of software, whether it's Linux or Windows. Control A is highlight all, Control V is paste. So the only part of the code that we're actually doing anything with is here. We looked at this. Initialize digital LED built-in as output. LED built-in output. Well, pin 13 is recognized as the built-in LED pin. So we could have said 13 here. Void loop. And once again, there's the digital write LED built-in high, delay, digital write LED built-in low, delay. Okay. We don't need any libraries for this, but we do need to load this code into our Uno. So it's just a sample, and this in the simulator, all I do is hit the play button, and it will compile and execute this code. The on light here shows that the Uno is on, and then see this L here. This is the built-in LED or pin 13 LED, and you can see it's blinking on and off. On for a second, off for a second. But I did say that we could control the outside world. So let's do that. Let's add something. So I just added an LED. And we also need a resistor. And the resistor goes on the hot side of the LED. Might learn this from trial and error, but I know from memory that the bent side is the hot side here. And then we're going to connect this to pin 13, which I said is also wired to this internal LED. And the other side of the LED goes to ground or negative. Now, let's run it again. And there. So we have a blinking LED now. We need the resistor to knock the power down a little bit, or we could smoke that LED pretty easily. It's pretty low power. Okay. So just for giggles here, let's do something. Let's see. Bear with me for a moment. Tabs away here and I lost one. I have completely lost the saved. Sorry about that. But we can move on to the next one here. Let's look at another blank project. case, there is a Hello World project, but it's using what we call a 2-line LCD. This is a really, really common display. It's the one on the QRP Labs radio I was holding up before. It's the stock display on all of the microBitX radios up to version 5. These are used in so many of these projects, but standard 2-line LCD, they all work the same. And all this is going to do is produce the words "Hello World" on this display. So we're going to do another blank project here. I can take this code and load it in our blank. And this one, once again, there's a lot of notes here. This is all comments. Now here's where we're including a library, liquidcrystal.h. We're initializing the library. We're telling the Arduino which pins we're going to be using and which portion of the LCD we're going to be using, which pins of that. And we're telling the program that we have 16 characters across and 2 up and down. That's our display, 16 by 2. We're going to print the message "Hello World" to the display. And then we do have a loop. There's a loop here, which is going to increment a number of seconds since reset. So it's going to print milliseconds over 1,000 each time since it starts. So it's going to be counting milliseconds. Then it's going to take that count, divide it by 1,000, and print the result as an integer. So we won't get long decimals out of it. But the code's very simple here. Now we do need to load a library. This one is called Liquid Crystal, one word. It's this one. I know you see there's a lot of stuff here, but because the library was called liquidcrystal.h, that is what it is. That is the name of the library, Liquid Crystal. This was the part that probably challenged me the most, was getting all the libraries loaded correctly, because you have to understand how they work. And sometimes you have to hunt them down. They're not always through these search tools. You got to find them from whoever wrote the program. But most of them are easy to search. All right, so we have our library in place. Now, I need something here that I'm going to actually control. So we need to add some parts. So we need a 16 by 2 LCD. Don't need the resistor. That's for controlling brightness, which we're not actually using a real display, so we don't need to worry about that. But you would have to wire this whole thing up. So if you look at this, it says LCD RS pin to digital pin 12. So I find the pin that says RS, click, 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 12. LCD enable pin to digital pin 11. Well, I didn't know what an enable pin was when I first started labeling, working with this. But I looked through this row and there's a pin that just says E and no other explanation. So I guessed that that was it, and I was right. So pin 11. Okay. Now, I know some of you are subconsciously saying right now, this is boring. And yes, you're right. So let's do like Graham Kerr or Julia Child used to do years ago in their cooking shows, when they get halfway through mixing something and throw it in the oven. Oh my God, it's done. They always had double ovens, and they opened up the second oven, and there's the souffle all finished. So here's our souffle. So I did all of the wiring based on this. The only thing here, there was one mistake where it says VCC here. It's actually supposed to be on the display, it says VDD, which once again, trial and error. Nothing else made sense, so I made that connection, and that got me going. So once again, this is going to say hello world and then count some seconds. So let's hit the play button and go. So stop. Let's do different. How about hello Lou? KD2 TVS. Hopefully we have 16 characters to work with. Ah, we lost the S. But you can make minor adjustments to this code just by changing things around. This is a very simple program, but let's say we wanted to count tenths of seconds. So we're going to divide by 100. Let's see. Now, of course, this is a web-based tool, so it's not counting in even tenths of a second. You can see it's kind of jumpy. One of the modifications I made to the Blinky program when I was playing with this was to get it to blink on and off faster than 1 second. But anything less than like half a second, and it really doesn't work in the browser-based one. But I think you get the idea. I do have one more program I'll load here, just to show you in the simulator. And this is one that's going to use the analog pins to take a sample of something from the outside and output the result to the digital pins. So this one's taking a variable resistor, in this case a sliding one because it's easier to demonstrate and control in a web interface, and then a bar graph LED display. And a bar graph LED is simply a stack of LEDs. We treat these as individual LEDs. I could just as well have put a whole bunch of those LEDs from Blinky here all in a row and done the same thing. See, there's a resistor for each one. So we turn this on, and basically it's just going to read my analog signal here coming into pin A0 or analog 0, and then it's turning that into a digital signal, how many LEDs to illuminate depending on resistance I'm dialing up here. You look at something like this, then I want you to think, you could take a very simple circuit like this, and in a lot of these radios that I've been building or we design, or even radios, simple radios that we might buy, there's something called an Agc circuit in your radio, which is automatically adjusting your receive gain so that you don't blow your ears out when you go from a weak signal to a strong signal when you have headphones on. AGCs are taking a sample of the receive gain. It's one of the ways that they work. Some of them are audio derived and won't be as accurate for the example I'm talking about, but it's still, you're getting a gain sample from your radio. Well, there's a point in that circuit where you could definitely get a flattened curve of resistance out of it, either through just adding a couple of components to it, or maybe that circuit has a nice little analog output that you could drive a circuit like this with. So as that resistance would change, you could have more or less LEDs show up here, which you've created an S meter. And if you calibrate that to some standard, it could actually be a decently accurate S meter. So just examples of what you can do. I'm going to show you one more thing on the computer. So I mentioned that this is just a simulator, and you're going to use, if you're playing with the board itself, you use something called an Arduino IDE. That's the software you use to load a program onto your Arduino. And something like Blinky. I can take that same code to kind of USB cable. USB port. I'll show you both sides of this, don't worry. So in here, we can go back to the Blinky project. And this again. And then load it into the Arduino here. Okay, so first things first, I'm going to plug the Arduino into USB. Hear that famous USB noise that Windows puts out. Now I have to know where that Arduino is sitting in my computer. So you're going to want to look at your device manager. Right here. And of course, if you're doing this on Linux, you would do some commands from the terminal to determine which serial port your Arduino landed on. But I can look at the ports here, and it says Arduino Uno is sitting on COM14. Okay. So first I need to pick which board I'm using. And I need to tell it where it is. It's on COM14. Okay. I've loaded this code in there. Now, in the interface here, the first button is verify. You can compile your code before you load it. And we just hit this and it verifies the code. It says down here, compiling sketch. A sketch is what an Arduino program is called before it's compiled. And it says done compiling, and there's no red here, which means that it worked. It's using 924 bytes or 2% of available space. All right, but if I hit the second button, upload, it compiles first anyway, but let's do it. So uploading. Okay. Some of the very simple programs that you're going to do on these when you're practicing require you to look at the serial monitor, which is basically an input-output. Some of the basic radio control programs I was working with leading up to this use the monitor. So, if I wanted to change frequencies, I would just, type the frequency in here and hit enter and it would change it. But it's basically what you need to know to get something like this working. If we were dealing with something like the LCD, the two-line LCD program, I would have to load a library. See, manage libraries here. I can search for libraries by using the manage libraries tool. And it's pretty extensive. Now, it's rare that you're not going to find what you're looking for in here. But the one that we would need if we were doing the LCD, which I'm not going to fire that up tonight, I have something else wired up with my 2-line LCD. We would load a library, and that one happens to be so common it's in this menu, and you can see right here, liquid crystal. And now you see this line up here at the top, it says include liquid crystal.h. Same thing we did in the simulator. So if we were going to do that, that's what we would see at that point. Turn off the screen. I think we've done enough of that. And I'm going to turn on my little remote camera here. So you can see what's going on here. So this is the board. And you can see blinkies going away there, on, off, on, off. And I'm running it all off of a 9-volt battery. This USB cable is a standard A to B cable, like the kind that comes with a printer, or doesn't, and you yell and scream because it didn't, but that is just a standard cable. This one came with an Arduino Uno learning kit that I have. Okay, let's look at another one. This is an ESP32 microcontroller, and this one has Wi-Fi and what we call LoRa, which we're not going to get into tonight. But this is a Wi-Fi enabled microcontroller, like an Arduino. Happens to have an OLED on it as well. This is for a project I'm just still thinking the whole thing out. But what that project is a combination thermometer and clock for my wood stove. Surface temperature, flue temperature, like that. And the basic program. And what's this showing? It's actually showing all of my Wi-Fi nodes. That's the stock program that loads on it when you get it. So that's just an example. Let's look at another one. I mentioned the BBC microbit. This board is cool. It's really a lot like an Arduino in how it works internally, but it has a lot more going for it, which makes it a lot more fun to work with without having to add things to it. This is the microbit, and you can see it has a little antenna on there. It has Wi-Fi and Bluetooth. It has a microphone. It has a very, very tiny speaker. And it has an LED matrix display and a couple of buttons for controlling it. So it's got a lot going for it to interface it with the outside world. And you see it has this funky edge connector there. If I want, I can just slide it into this adapter here. And then I have a whole row of GPIO pins, like an Uno. So, but what does it do? It comes with a program already installed on it. Sorry, I don't have my tripod for the phone tonight, but we're going to throw this in. A couple of you have already seen this. Here where you can hear it too. saying hello. Now it says press the A button. Now it's saying press the B button. Now it says shake. It wants me to shake it. Okay. Now it says tilt. This one's kind of cool. Tilting it to make the dots touch. It says clap. I can't, I'll snap. See, it's counting. And now it just says wow. But it's just showing that it has a microphone, it has a speaker, it has an accelerometer. Cool. This is one of those things, I've been reading about these for a while and I always wanted to try one. So I went and grabbed one. And I'll probably use it for something. And I can actually use it for the big project here, which was where I finally ended up in this journey. And let me take this out. Okay. So what we have here, and I'll show you component by component. This is a TEA 5767 FM radio module. Now, the little chip here, see there's a chip on a carrier board. That alone is an FM radio. And it's addressable by a microcontroller, what they call I2C bus. We can control it, and it will receive FM stations and put out audio. The rest of the board that it's on is simply an audio amplifier, power regulation, and just wire routing. It's giving us a connector for an amplifier, top one, or headphones. It's giving us a connector for an antenna. Connectors here for voltage and the I2C bus, which is going to control it. All right. That should look familiar to everybody. So that's just an original official Arduino Uno board. Okay. Over here, you probably recognize the 2-line LCD from our simulator. And it's on a breadboard. And then, of course, the inline pins in the breadboard are all connected. So I have these wires going back to the Arduino, similar fashion to we did in the simulator. The extra components here, there are 2 buttons, an up and a down button. And then there's a little board over here to the side, simply because I ran out of room. I was trying to avoid having to have the contrast adjuster, but you actually, turns out, have to have the contrast adjuster to make this thing work. So, but this whole mess here is what we're talking about. Now, I do need audio, so bear with me for a moment. And yes, we're going to use the same amplifier that didn't work on Saturday. The that should all work in here. Probably because Steve isn't here. I'm convinced, Dave, that it's Steve that puts out the RF interference.
It's certainly possible. I've been known to be a little charged myself occasionally, so.
Okay. So you see everything here. Let me just fish the 9-volt battery we were using on the other Arduino out. With a 9-volt battery. Okay, so you can see it's still off. Let me get microbit out of the way here. Okay. So I'm just going to plug this thing in. I know it's kind of hard to see that display, but it does say 88.1. And I'm going to hit the up button. There's our local classical station. Hold the button in. And actually, if you hold it in longer, it actually does move faster, which means somebody thought of putting that in the code. But if we tune up to, let's say, 96.9, local rock station, and you can see this thing is glowing, just telling us that it's on. And the Arduino is doing the same. Of course, WPDH, which is the giant tower outside my window. This is no great feat. I can pick this up with my silverware drawer, as I say. But you get the idea. The point. Well, the point to all of this is that this, on a much more advanced scale, is exactly how these projects work and these radios. Granted, something like an ICOM IC7300, which so many of us own, or a 991A from Yaesu, or a lot of these radios have something a heck of a lot more sophisticated in it than an Atmega 328. For an example, you know, Matt's TS140 or my old TS440. Even something as simple, you know, or as advanced as an ICOM 7000 are using really just a microcontroller. Sophisticated maybe than an Atmega 328 in some cases, but all of these radios are all based on these circuits and these designs. And as you get into projects and you look at these schematics and you realize this is what's going on. Now, as I keep pointing out, I think even though none of this is new to the people who design this stuff and build this stuff, but the fact that the programmers have made more progress than the hardware designers at this point means that there's a lot of really cool stuff coming, because people are going to look at the example code that some of these people have done, and they're going to come up with some really neat things. What does this do for you? Well, if you purchase something that uses Arduino code, and in the case of project U8TE's projects and a number of these other people, the code is open source in many cases. Look at the code. You know, throw your call sign into the startup screen. Change the timeout for long press and short press if you're not comfortable with it. Change the tuning slew rate, you know, for turning the encoder and how fast it tunes. Play with it. You always have the original code to fall back on. So as long as you save the original or know where to get it, you can't really break it. So there's a lot of stuff you can do with this. And there's definitely a lot of projects, even just around the house, I was saying I want to do this thermometer project. I also have a project that came with the Raspberry Pi Pico from a company called WaveShare, which makes a clock project from them. And I have like a little weather station, not one that interfaces with like, my outside weather station, but one that just reads the weather from the internet and displays it with little icons of, clouds or sun or snowflakes. But there's a lot you can do with this, and just really no end to it. And when you run out of space in an Atmega 328, definitely get more sophisticated. And I know come up, and someone is thinking it, and someone will ask probably, why not a Raspberry Pi for all of this? Raspberry Pi has those GPIO pins on it. And you can definitely do everything I've shown you with a Raspberry Pi. The difference is it's clunkier and more cumbersome for basic tasks. So if you're designing something that's going to do one thing or a couple of things, sometimes an Arduino is a better choice because it's more stable, there's less going on, it's a lot more efficient. And see these things in all of these radio projects, and you won't see a Raspberry Pi, is power. Because they're so efficient, because they have such lower clock speeds and less memory and everything else, they don't draw a lot of electricity. They're very low power. And why you can go out with, a radio for summits on the air or any of these other things, several hours of power out of a tiny little battery. You wouldn't be able to do that with a full-fledged Raspberry Pi in it. I'm not poo-pooing the Pi at all. It's a fixture in here. And some of you know, I do the Raspberry Pi forum at Ham Radio University every year. I love these things. They control a lot of stuff around here. And we all have them. Funny thing is a lot of you who never had them before have them in the form of a hotspot. So there's a lot of them out there. Pis are great, but for certain things, and some of these things that we're looking at, something like an Arduino is going to be better. Here's Pico, by the way. So, and cost is another thing too. I mean, Raspberry Pis aren't expensive, but that Pico is $5. And even though you can use the same code and compile it onto it, Picos are normally programmed with something called MicroPython, so something else to learn. But once again, if you know what it does and you can read the code, you should be able to figure out what it does and different words mean. So, all right, that's the meat of the talk. And if anybody has any questions or wants to open a discussion up, it's fine. Guess I'll look at the chat here. Yeah.
There's a message in there directly from me, Neil.
Yeah. Right. Well, let's see. We'll look at the interaction here first, and then we'll go with that. How's that, Dave?
Yeah, that's fine. However you want to deal with it. I just jammed it in there so you can see it happening.
All right. And yes, Mike, I see you. But that was 6 minutes ago. Okay. Well, I don't see your video, but I see that you're here and listening.
Okay.
Does anybody have any questions or comments?
Can you hear me, Neil? Can everybody hear me?
Yeah, you're loud and clear.
Great. This is my first time at a Zoom thing, so this is like, a whole new world here. Well, I've been playing around with Arduino for quite a while, and I've been meaning to actually do the very project that you're doing. I have a TEA chip, but it's just it's not quite like put together. I have to put like the rest of it. It's just a tiny little chip which is on a little board itself, but it doesn't have the attachment for the antenna yet and everything. I have to do all that. but it is an Arduino based project. But I've got a few other stuff happening here. I don't know. This is an Arduino based project. I don't know if you guys can see that, but that's a matrix. So I was kind of giggling when you showed me that small board that you had that had the little 5x5 matrix on it. So this is an 8x8 that I built, a small one. I've got a much larger one with a flame sketch put on there. So I was able to find these sketches on GitHub. So there's quite a few people that do sketches for, depending on what you want to do. But it's lots of fun. I'll give it back to you guys. But I'm interested in that other project, and eventually I'll try to put together an FM radio. I think it'd be a lot of fun.
Thanks. And as I said, I've known Joe a long time. We figured out the other day we've known each other since kindergarten. But he is a ham, and I think he's gonna. We'll be seeing a little more of him here and there. Yeah, TEA 5767 board that Joe is talking about is the postage stamp like thing that was on the main board that I used. And they're a little tricky to deal with. And I'm sure Joe may know this just by looking at it. It's almost like surface mount work, because it has these little tiny indexes of the board, and you really have to solder it down to like a something with solder pads on it. I did some digging around, and I found there's one company in Canada that made carrier boards for the thing, and I managed so that you can surface mount the thing to the carrier board, and then you get actual that you can solder wires to. So, but they were hard to obtain, and the place had a pretty high minimum shipping fee. So I decided if I was ordering stuff from them, I might as well get something else. And that's where the microbit came from. So I ordered the microbit and a couple other things from them. But the number of other FM radio on a chip modules out there that you can use to do just a sample project. Lou, SDR radio kit for sideband based on the Arduino recommendation. Good website. The W2NDG project is a little advanced, but the book, will walk you through it step by step. But the fact that they're going to kit this thing will make it a little easier to get the whole thing together and understood. This is most likely the most complicated and expensive kit that 4-state QRP is ever going to offer. I'm sure it won't be really cheap, but it's not going to be $500 either. It'll probably be in the $200 to $300 range, I would guess. But just being able to build, your own software-defined radio project like that, interesting. Another one that's coming, and I did a talk on this for the Makers Group last week. Farhan, the creator of the MicroBitX, which Matt has one. I have a couple of them. He's working on something called the Esp32. And what that is a software-defined radio similar to the T41 project, but more of an all-mode, all-band type of thing. And that radio, if it ever does reach production, uses a Raspberry Pi as its processing core. It's not designed to be a portable QRP rig. I think it's a 20 or 40 watt radio out of the box when you build it. And knowing Ashar, the kit version will probably be more like Lego, as his other kits are, where it's just a bunch of boards, you put them in the case, and you put a bunch of ribbon cables together. But it's still the idea, you get to see how it works and what's going on, because you can follow the project along with him. So there's a third one, which the True SDX. I see your hand, Matt. I'll call you on you in a second. The True SDX project originally began as a modification of this radio, the QRP Labs monoband CW rig here. And there's even when you buy one of these kits, it comes with a little adapter board so you can turn it into a sideband radio. Hans acknowledges the project. You get a monoband radio at that point, but it's still a neat idea that you can do that. Hans has been working for several years on a radio called the QSX, which is a multi-band, all-mode, SDR-based radio. It's not going to be this size, but it's looking like a pretty good project. Apparently, I mean, he doesn't talk about it much anymore because people just hound him about these things. Give you an example of how popular Hans's designs are. This thing right here, this is a version 1. Version 3 came out last week. 2,000 of them were offered. 2,000 of them sold out in less than a week. And think of how big our hobby is. It's not a big hobby. The original model that I have here, I think he offered like 300 of them, and they sold out in 7 minutes. So Hans's stuff is very popular. He's keeping the QSX quiet at the moment because I think he's just going to announce it when it's done. Everybody's been asking him so much about it because he did tease it a few times. I think he's sorry he did, but we will eventually see it. It's going to sell like hotcakes. It's going to be a very interesting radio. And knowing Hans, the monoband starter kit will probably be a little over $100, and the multi-band add-on will probably bring it up to 200 or less. And for those of you who do want to try the Army radio here, this is once again a 5-band, 5-watt radio that does sideband and CW. These are $137 shipped. So that's the other thing you get out of using this type of design in your radios is low cost. There's not a lot going on in these radios. They're very simple component wise. So anyway, Matt, you had your hand up.
Thank you, Neil. You pretty much answered my question. I was looking at the QDX, and I'm thinking about pre-ordering one, but apparently there's going to be quite a wait. So I don't know whether I should pull the trigger or wait and see. But like you say, he's releasing them in batches, so I should probably want to get in.
Well, the QDX, which is this one,
Yeah.
he still had some available the other day. I don't think he had run to 0 yet, but he'll have another batch coming. But this radio is a window into what his next radio is going to look like. And one of the really cool things that Hans did this time, and those of you who deal with firmware ever on devices will love this, because loading firmware onto devices, well, look at that. Is that one of those name badges, Jim? Yeah. Loading firmware onto devices can be tricky. And if you don't know what you're doing, you can brick a device, which means leaving it unusable. There are ways to recover from that, but that's even harder. But I've done both. I've bricked things and recovered them from the dead. But doing firmware sometimes can be a headache. And the functions of these projects can be a bit of a headache. What Hans did in his latest design, and will carry forward into all of his new designs that he's doing, is that once you have this plugged into your computer, you can open up PuTTY or another terminal emulator, little command line, tool, and you get a menu, a text mode menu that allows you to change parameters, change settings, and load firmware. And he designed the whole thing with a little bit of flash memory. So all you do is when you plug this into your computer, you see a little tiny flash drive will show up, like a USB drive. You put the firmware file on that drive, and then you go into this thing and you say load firmware. It grabs the file, it reboots, and it's done. He's made it ridiculously easy. Whereas with this thing, I have to actually load a bootloader on it first using an Arduino Uno, and it has to be a pretty new Arduino Uno to work correctly. Or else you get into this really crazy inception thing, because then you need another Arduino Uno to load the bootloader onto the first Arduino. I won't get it. But And then once that's done, then you hook this up like it's an Arduino through its USB port and load the firmware onto it. And it doesn't always work right. And you have to kind of know what you're doing with libraries and all that other stuff. And a lot of people haven't played with this. It's like I like to show the basics, because at some point, if you have a device that's going to ask you to do this, you'll feel a little more comfortable about it. Another cool thing about Hans, though, as small as he makes these radios, if you look at the boards in them, he still uses a full-size socketed Atmega 328, like on this thing. In those radios, he still uses that full-size chip. And that's because if you really are that uncomfortable with doing the firmware and changing things on your own, he'll sell you a new chip with the new firmware on it and send it to you. And all you have to do is swap the chips. Nice guy. So, all right. Anybody else? Right. So Dave,
Yes.
let's see. Definitely questioning a bit. Say Lou and Matt were the ones that came up with as far as Steve's
Steve's offer. Your audio is dropping out a little bit there, Neil.
oh, sorry about that.
I don't know if it's a connection issue or what. Do you want me to mention what Steve mentioned, or do you want to just go ahead and do it?
Oh, yeah. I don't know. I'm not sure what's going on with the bandwidth. Yeah, but UVP said that my feed dropped as well. All right. Sorry. Hopefully I'm coming in okay now. Steve, K2GOG has offered a couple of Arduino Unos with some bits and pieces to somebody who's interested and wants to play with these things. I know a couple of you already have them, but somebody is interested. Steve has offered some freebies.
What he mentioned to me on the phone was that he has 2 Arduino Unos that will come with a few bits and pieces and a little breadboard, enough to get started playing around with Arduino if you haven't done it yet. So if somebody's interested in giving it a shot, those are available.
Anybody?
I've got some extra boards here. If anyone is interested, I've got some new ones that I picked up from Tata Electronics real cheap. So if we're like shorthanded in the group, or if somebody wants to try one, you know, I'll figure out a way to get it to you somehow.
It doesn't look like we've got any takers, so okay.
I get the feeling that even of our questioners, a lot of them, like Joe here, have 1 or 2 of these laying around and haven't pulled them out of the package yet, or got a little lost trying to figure it out. But yeah, if anybody wants one, and when I'm done with my current project, I'll probably have a spare or 2 myself. But
I have one sitting on my shelf, as well as another version that apparently you can log into and change settings on it somehow by logging into a website of some sort.
Mhm.
Can't remember the name of it.
yeah, they get pretty sophisticated. The Arduino, official Arduino people even came up with a board that's similar to a Raspberry Pi. It has an additional full processor and all the I/O that the Pi has, but it's hard to match the Pi in support and just sheer numbers of available programs and everything.
Yeah, but as you said, the use case is completely different. Arduino's low power, doesn't have a operating system, well, most of them, and doesn't have the same issues with coming back from power interruptions. SD cards don't go bad over time. It's a much more stable platform for a simple system rather than trying to run a full operating system on a Raspberry Pi.
Something up real quick here for Lou.
I could also add that if you're just doing like a single program, something to where you would just be popping the chip out and putting it into another, you can make your own Arduino board if you like. If you're into making your own circuit boards, like do-it-yourself home circuit boards, ferric chloride and etching the whole 9 yards, and you can reproduce, just the basic circuitry to support the chip, and then you can program it through an Uno and then pop it out and embed it into whatever project you're using. So it's pretty handy that way as well. Then you can just buy a bunch of pre-bootloaded chips and program away and put them in all of your favorite boards. I did that for a while. I got like a bunch of boards around here.
I just put thanks, Joe. And I've seen an Arduino kit as well that someone was offering a while back with a pre-done board where you could solder an Arduino together. So, and there's some of the projects based on these. There's some retro projects also. There's Nuts and Bolts, which is a maker's magazine. They had a project to build an old SI 8080, one of the first personal computers. It didn't have a display or a keyboard really. It was just a row of LEDs and switches. But you can build a simulator for that. And there's a number of other retro projects that you can do.
I don't know if you guys can see that there. There's a Arduino circuit just for a temperature sensor and an LCD screen. So that's a homemade job.
That is cool. And Joe, you do guitar accessories, right?
Yeah, I do those too.
Yeah, he makes effects pedals and things like that. Neat stuff. The link I put in the chat is Lou mentioned that he's seen these true SDR radios on Banggood. There's a lot of metal cased USX or USDR, they call them, radios all over AliExpress and Banggood and eBay. Most of them are crap. They were based on an early version of the design that these guys came up with, and they there you go. Sorry, Lou, I thought you dropped out, but there you are. Couldn't find you. So they're different versions of the code and the actual hardware design. The problem is that this design is very, very component dependent. And if you change the latest little thing, like you change the design of the board, the filters have to be completely redesigned. It's a very tight design. So a lot of the radios that were taken from the project early don't work very well. They're not very efficient, and they're not, means that according to our license, they're illegal. Yay! Which means they're putting out too strong second, third, and so on harmonic signals and other spurious emissions. Not efficient either. This radio should be able to do 5 watts on every band at 12 volts, and those other ones can't. So the link I put in the chat is the official one, and it's the first official one that's actually been consistently working from all the reports. There were a couple other companies trying to do this kit, and they've been falling on their face a lot lately. Hopefully they'll get their act together, but for some reason this Chinese retailer is doing it. have sold 585 of them, according to this AliExpress blurb. And they're also selling on eBay and a couple other express stores. So that's pretty good. They moved a lot of them. All right.
Do you have a if you have a moment, would you send me a link? The thing about the AliExpress is, are they selling them from US stock, or are they coming directly out of China?
China. But it wasn't too bad.
It might be right now.
Ordered one. Did you order a new one, Matt? Not sure if he's still with us.
He's still there, but he might be stepped out for a moment.
It really wasn't that bad. They're from China.
My concern is the lockdown right now over there.
The only effect it had on me was they emailed me and told me they couldn't get the color of the case that I had originally chosen, and that I said the green was fine, and they couldn't do the, I don't know, style of the letters was different. I think I had wanted one with white raised letters, and they did the black recessed letters instead. And it's because the 3D printer that they were using to bulk print these was in Shanghai. And Shanghai is where the lockdown is.
Right.
But the Uptech store is not in Shanghai, so they were able to get everything together and do a case from another source. So,
Okay.
Matt, what are they telling you?
About shipment time?
Yeah.
I'm to expect at the end of this month or beginning of June, so a couple of weeks yet.
Did you get notified that it shipped yet or no?
No notice that it shipped. They did, however, contact me to ask me my call sign, so I know it's in process.
Yeah. So, I mean, they're processing a lot of these. Once mine shipped, Dave, it was only a couple of weeks for it to get here and get through customs. So,
Right. Okay. Cool enough. It's a cool little radio. It really is.
it is. And I know there's going to be, further versions of it at some point, maybe. We'll see. I'm going to try to build a high band version with the one that I just got.
That's
So
going to
this one does 80, 60, 40, 30, 20. So for
Nice.
those of you sideband people, 80, 40, 20.
Right.
But they have the values for building it for 80, 40, 20, 15, 10, which they call classic version, or you can do a 20, 17, 15, 12, 10, or high version. So I'm going to do a high version because it'll complement my low version. And then 2 of these will get me every band. So
You just have to make sure you have different colors so you know which one does which.
yeah, there you go. Well, I do. The other ones are kits. So they came with the orange case. And then I'll have a couple for sale once I get them all together. There's a certain amount of tweaking involved, and I think that's why this Uptech store is doing so well with them. Is the tweaking. Show you. Green. Uptech store. Radio. It's funny is they even show it with the little SMA to BNC adapter on the side. They usually include that for free. They give you a bare power connector so you can make your own power cord. That, as some of you have heard me talking, that's the only problem I've had with mine is the power connector coming loose from the board. So I've got some tips and tricks from various people how to get around it and fix it, but I'm going to try to fix it before Thursday because I might be wanting to use it over the and you can see, I'll show you in my QRZ log here.
So take the standard 2.1 millimeter, whatever it is.
It does
connector.
not.
It does not.
It's not. It takes a much smaller connector. So I made like an adapter to go from that to the 2.1, and then, you know, sorry, camera's off for a second, but I'll show you in my log here though. Sort by date again. Oh, I have a filter on. 6 meters. Okay. So in my QRZ log, you'll see there's a few here marked true SDX. Bulgaria on 40. Star Wars Special Event Station here from Western Pennsylvania. They were out near Pittsburgh on 40. If you ever talk to this guy, Dave, who hangs out on 40 meters this time of year at night, if you look him up on QRZ, his last name is listed as surname, but that's not his name, obviously. But he doesn't have email or own a computer. But yeah, I talked to Dave, and Slovenia on 20 meters. So it's working. And the cool thing about it is if you power it with 5 volts, it'll put out 1/2 to 3/4 of a watt. So you can power it through its USB port with like a USB charging battery. And Dave K2LD, or Bob K2LD, heard me up on top of the mountain in Tannersville using 1/2 a watt. And I was able to hear my own signal on an SDR in New Hampshire using 1/2 a watt. So it's a neat little rig. Yeah, so what I did with this one is I made a cable, an adapter to go to a 2.1 here, and then did ink, which I bent and let cool in its bent position, and then zip tied it on here. Unfortunately, in the process of tightening it up, I torqued a little too much on the power connector again, and I'm gonna have to open it up and redo it again. Someone told me to use more heat than I'm using. I'm using a lot of heat, and I'm afraid I've already damaged the pads on the board, but I think I've also traced the circuit to know where I can tap 12 volts in on the board other than where the connector is, so I may do that. All right.
Very cool. All right, so any further questions before we close this out here? Nope.
Can you
Right.
can you repeat that whole thing again?
You couldn't hear me from there? I'm pretty loud.
I
My
just
window-
connected, so I need the whole presentation all over again.
You're in Connecticut?
No AA.
Oh, let me put the simulator in here as well. Walkwee.com. And like I said, there's other simulators out there, but I liked the simplicity of this one. All right, so that's in the chat as well. All right, you could stop recording, Dave.
All right, very good. Thank you very much, Neil, for that presentation. Very cool. And I will have it up on the OMARC YouTube channel in a day or so. All right, thank you very much.